Myself, Joshi SS, Assistant Professor, College of Engineering, Nukkatara. I welcome all of you to the 10th session of ATAL-FDP on Green Energy Solutions, Building a Sustainable Carbon Neutral World, conducted by Mechanical Engineering Department, College of Engineering, Nukkatara. So the next topic is effective GHG mitigation and estimation techniques for building and transportation sectors by Dr. Sreekanth KJ.
Thank you. First of all, thank you for inviting me for this session. I am Sreekanth, working in Kuwait Institute for Scientific Research, and the topic is effective GHG mitigation and estimation technique for building and transportation sector. So, before starting this session, most of you might have seen this caption: "Nobody on this planet is going to be untouched by the impact of climate change." This caption, which is actually presented by the previous IPCC chairman Rajendra Pachauri, who is an Indian. So what I am going to tell today is, we all know that every breath that we take, or every step that we walk, or every light that we switch on has an impact on this planet. And we all always heard about greenhouse gas emission, its reduction, etc. So in other words, we can say every action that we take, whether it is flipping a light switch or choosing a mode of transport, that our everyday transport, or constructing a building, even though we all need building and houses. So all this has an environmental impact. So however, what if these actions could not only reduce the greenhouse gas emission, but also led to a cleaner and more efficient world? So in this presentation, we will see some strategies, some tools and innovations that are revolutionized how we design our buildings and manage transportation system to align with the global sustainability United Nations goals. So there are now cutting-edge technologies available, like AI-driven tools, energy systems, alternate fuel like green hydrogen, all this stuff. So all we know, the greenhouse gas emissions are actually an undeniable part of our life. But the most good thing, or the positive thing, is we have the tools, the knowledge, and the collective will to rewrite the story that is going on. So you just imagine a future where there is a building, or there are buildings which are energy efficient and actively contribute to the grid through the rooftop solar panels, what you can see in this picture, and the battery storage, etc. Also, there are cities where electric buses are glide silently down the street, which is designed for cyclists, pedestrians, etc. So, and all these things are powered by the clean and renewable energy. So these are actually not just futuristic vision. There are cities or realities within the reach. So in today's presentation, I am going to cover two major topics. One is the building sector. The other one is the transportation sector. The major topic that I am going to cover, an overview is presented here. I will give you an idea about certain words which are associated with the greenhouse gas emission, etc. One is greenhouse. We all know greenhouse gases. They are a set of naturally occurring gases, man-made gases, which is on the Earth atmosphere and trap heat, which are allowing sunlight to pass through. Similarly, there is another word which is called the greenhouse effect, which is a phenomenon that occurs when gases in the atmosphere trap heat emitted by the planet. And another term, in this slide, I have written water vapor as one of the greenhouse gases, because this is the most important greenhouse gas, which is responsible for around 40 to 67%, around 40 to 67% of greenhouse gas effect. But the global concentration are not directly affected by human activity. So in some textbook or some literature, you will not see water vapor as the greenhouse gas. And another term here you can see is IPPU, which is industrial process and product use. And another term which we will see today is climate variability, which is variation in climate pattern, which is beyond any individual weather event that occur within the small time frame. So in this slide, you can see the sector-wise GSG emission in India in the last decade. You can see the power sector is contributing because Indian power sector are mainly coal-based. So the power sector contributes to most of India's emission, and the lowest one is agriculture. So this slide shows the global emission by sector. You can see around 15% is from the transport, and approximately 7% is from the building sector. So together these two, when we avoid the industry sector and the power generation sector, together the building sector and transport sector contribute to approximately 20 to 25% of total global emission. And the increase in Earth's surface and ocean temperature is presented here. These are all just some introduction to what we are going to see today. Because of all these reasons, the GSG emission estimation for building sector and transportation sector are important. And this slide shows global warming potential compared with the carbon dioxide. So what is GWP, or global warming potential, which are calculated? It is a ratio of the radiative forcing that would result from the emission of 1 kilogram of a greenhouse gas, which can be NCH4, N2 or anything, to that from the emission from 1 kilogram of carbon dioxide. So we will take usually a particular period of time, which is 100 years normally. So each greenhouse gas actually differs its ability to absorb the heat in the atmosphere. So HFC, PFCs are most heat absorbent, that is hydrofluorocarbon and perfluorocarbon. Methane traps over around 21 times, whereas nitrous oxide traps around 310 times. So this shows the carbon emission per capita for selected countries. You can see United States is the maximum and where India stands. So with this introduction, the GSG mitigation and estimation for building and transportation sector, we are going to our topic, which is building and transportation sector, GSG mitigation and estimation. So these two sectors are the largest contributor. We should have some effective mitigation strategies in these areas, which are essential for achieving the climate change. So this presentation, from here onwards, you can see an overview of the different techniques used for GSG estimation and mitigation, emphasizing the importance of accurate measurement and innovative practices. So the importance of GSG estimation, there are different aspects. One is estimating the GSG emission is essential for, one reason is regulatory compliance. Any country, any nation has some jurisdiction. So many jurisdictions require organizations to report their GSG emission as part of environmental regulation. And the second parameter is the corporate responsibility. Whether it is a company or university or institution, anything. So they are actually increasingly held accountable for their environmental impact. And the GST estimation help to demonstrate this commitment to sustainability. And the third one is cost saving. So identifying energy inefficiency, which can lead to significant cost saving through reduced energy bill. The another parameter for the importance of GST estimation is the stakeholder engagement. That is, transparent reporting of GST emission can enhance an organization's reputation, and it can foster the trust with the stakeholders. In the GST mitigation technique for building and transportation, first I will start with the building sector. There are 4 subsectors, which are energy efficiency improvement in the building sector, retrofitting, integration of RE sources, renewable energy sources, adoption of smart technologies. So the first one is energy efficiency improvement in the building sector. So here you can see the different strategies for building energy efficiency. So as the energy consumption in buildings accounts for a significant portion of global energy use, improving the energy efficiency is crucial for reducing the greenhouse gas emission. So lowering energy cost and promoting sustainable development also come along with this. So in the next section, next slide, you can see what are the different ways here? So the building sector, you can see energy consumption and carbon emission. So as the demand for energy continues to rise, it becomes increasingly important to focus on energy efficiency improvement. So what are the key areas where energy efficiency can be engaged, including the building design, retrofitting, existing structure, the integration of renewable energy sources, the adoption of smart technologies are all coming under this section. So the first one is passive design strategies. And the passive design strategies generally utilize or use natural resources to maintain comfortable indoor environment. At the same time, it will minimize the energy use. So these strategies include, one is the orientation, building orientation and layout, which is actually positioning the building to maximize the natural light and minimize the heat loss. And second one is insulation, building insulation, and using high quality insulation material to reduce heating and cooling demand. The third one is natural ventilation, which is designing the windows and opening to promote airflow and reduce the reliance on mechanical cooling systems. So these, all the three will come under the building fenestration area. So the previous slide, what I have shown is presented in this slide: orientation, insulation, and natural ventilation. And the next one is, other than the passive cooling, the next is energy efficient materials. So the materials, energy efficient materials, actually they play a crucial role in building performance. Some of the examples are high performance windows, which is double or triple glazed windows or with a low emissivity coating to reduce the heat transfer. And the sustainable building materials, that is utilizing or using the recycled or sustainably sourced materials to lower the environmental impact. So that is presented, that is shown in this slide, energy efficient building. There are two aspects. One is the low impact and the high impact. Similarly, when we consider the efficiency, it can go from low efficiency to high efficiency. So sustainable building materials, if we use for the construction of building, it will be having high efficiency and high impact. Whereas conventional material will have low efficiency and low impact. Then comes the retrofitting of existing structure. So retrofitting, before doing the retrofitment in any building, we have to do energy audit, which is an essential part for identifying areas where energy efficiency can be improved in the existing building. So these audits assess the energy use pattern and it will recommend specific upgrades. So how the energy audit is done, that we will see in the coming slides. So one of the aspects for retrofitting is enhancing the building energy efficiency, that is HVAC, replacing the HVAC, that is heating, ventilation, and air conditioning systems with energy efficient models can lead to significant energy saving. Different options are variable refrigerant flow system or VRF system. These systems actually provide precise temperature control and reduce the energy consumption. And another one is smart thermostat, which are programmable thermostat that optimize the heating and cooling schedule based on the occupancy. So which is presented in this slide, that is how we can upgrade the HVAC system. Nowadays, along with the VRF system, people are using VAV system also. VAV means variable air volume system. This VRF, VAV, not specifically used in small individual buildings, but if you are having an institute or a commercial building with many floors and many zones, we can use VAV system, variable air volume system, where the air volume supplied through using an air handling unit, AHU, to a particular specific region can be controlled, so that it will be automatically upgrading the system. And the other one is, the third point is integration of renewable energy sources. So integration of renewable energy sources, incorporating this RE into building design can further enhance the energy efficiency. The various common practices include solar panel, that is installing the photovoltaic systems to generate electricity on site. All of you know that. Solar water heating, utilizing the solar energy to heat water, reducing the need for conventional water heating methods. So renewable energy integration, installing the photovoltaic systems, it can be solar thermal or solar PV, And some of the countries are using geothermal heating, that is implementing the geothermal system. It can also provide sustainable heating and cooling solution. So the next one is adoption of smart technologies. So the smart technologies for building efficiency can optimize the energy use in building through automation and also real-time monitoring. All of you might be know about IoT-based systems, Internet of Things, IoT-based systems. So the key technology used, building management system or BMS. It is a centralized system that controls the lighting. That is, for any building, HVAC is the major energy consumption area. HVAC. The second one comes the lighting, and the other building systems for optimal energy performance. So the BMS, or the Building Energy Management System, BMS, it is a centralized system that controls the lighting, HVAC, and other building energy system to optimize the energy performance. The second one is smart meters, which are devices that provide real-time energy consumption data, enabling the occupant to make informed decisions about their energy use. So smart building technology, that is building management system, these systems optimize the energy use, and the smart thermostats are also there, which are programmable thermostat that can help in reducing the energy consumption by adjusting the temperature based on usage pattern. So that is presented here, the BMS building management system. It controls the lighting, controls the HVAC, and optimize the energy performance. And the smart meters will give the real-time data, which can be used for informed decisions and energy consumption monitoring. So the smart building technologies are actually revolutionizing the way we design and manage the building. So these technologies actually integrate the advanced systems and devices that enhance the efficiency, sustainability, and the comfort of the built environment. So these slides explore the various components of smart building technologies, their benefits, future trends, and shaping how we can shaping a dynamic world. So the components and benefits of smart building, they utilize actually IoT devices, automation systems, data analytics to optimize the building operation. So by connecting the various systems such as lighting, heating, ventilation, air conditioning, security, energy management, smart buildings actually can significantly reduce the energy consumption, improving the occupant comfort and streamlining the maintenance process. So in this one, the right side, the IoT devices, automation, and data analytics, they are actually part of how the system integrates, and the other side where you can see the occupant comfort, which is most important thing, along with energy management and the maintenance process. So these are the major components and benefits of smart buildings. So the key components of smart building, one is the IoT sensors and devices. So these are devices that collect real-time data on various parameters, such as for any building. Inside there will be the major parameter that needs to be collected or checked is temperature, humidity, occupancy, and energy use. Occupancy means how many people are sitting, or what are the time where people are more or people are less. When there is less occupancy, more occupancy. Though occupancy of that particular zone or building or a room is most important parameter. The temperature, the humidity, and the energy use are another parameter. So IoT sensors and devices are used. So this data is crucial for making informed decision about building operation. The other parameters are humidity, air quality, and dehumidification are there in the humidity. Space utilization and security are under the occupancy pattern. Similarly, energy use, we will check whether there is energy efficient things or not. So the building management system operation, that is BMS, it actually integrates the various building systems into single platform. That is the most important thing. For any commercial big building, there is a BMS office or BMS system which will integrate the various building systems into a single platform, so that it will allow for centralized control and monitoring. So this system can actually automate the process such as lighting control, HVAC adjustment based on the occupancy pattern. So that is the major thing that is happening in any BMS. Based on the occupancy pattern, how the lighting has to be controlled, how the HVAC systems has to be adjusted. So that will be done based on the occupancy pattern in any building management system. The components of energy management system or EMS, another aspect of this one, that is EMS focuses on optimizing the energy consumption. BMS, in the previous slide, we saw what BMS is doing, building management system. Whereas here, EMS actually focuses on optimizing the energy consumption by utilizing the usage pattern and identifying the areas of improvement. So how the energy use for a particular period, maybe 1 month or 1 week or 1 year. Normally, we will not collect for 1 week, maybe 1 year or 2 years. So that particular period, the usage pattern is identified and it will be analyzed. So this EMS system can also integrate renewable energy sources such as solar or wind or anything to enhance the sustainability. So this slide shows a smart lighting system, that is natural light and occupancy detection. So intelligent lighting systems can be used in any BMS or EMS. So they can adjust the brightness and the color based on the natural light level and occupancy, and leading to energy saving and improved ambience. So for any zone or any particular room in a commercial big building, office building or any building, the smart lighting system will can be used to optimize the energy efficiency, and the energy consumption can be considerably reduced because these systems will automatically adjust the brightness and color. So the advantage of this system, that is smart building technology, benefits or advantages or benefits of smart building technology. One is energy efficiency. That is, by optimizing the energy use, the smart buildings can significantly reduce the operational cost and carbon footprint. The second one is comfort enhancement, enhance the comfort. That is, automated systems can create a more comfortable environment for occupant by adjusting the temperature and lighting based on individual preferences. Similarly, the safety and the security improvement. So advanced security systems provide better monitoring and control, enhancing the safety of occupant and assets. Then data-driven decision making. So real-time data analysis, which will enable building managers to make informed decisions and regarding the maintenance, energy use, space utilization. So these are the advantages of smart building technology. One is a data-driven decision making, improved safety and security, enhanced the comfort and energy efficiency. So the future trends in smart building technology, one is artificial intelligence usage. That is, AI is going to play a crucial role in, especially in predictive maintenance and optimizing the building operation by analyzing the vast amount of data. Then sustainability focus is another area where when the environmental concerns grow in the small sector like an institution to up to a country level or a nation level or United Nations level also, you can think about it. So when the environmental concerns grow, smart buildings will increasingly incorporate sustainable practices such as energy efficient design and renewable energy sources. Then integration of 5G technology is another future trend. The rollout of 5G network will enhance automatically, it will enhance the connectivity and enable the faster data transmission, improving the performance of smart building and the corresponding systems. Similarly, user-centric design. So future smart buildings will prioritize occupant experience, not occupant's experience. For a particular occupant, how it can give the maximum comfort. So utilizing the personalized setting and interfaces to carry out individual needs. So the user-centric designs are going to happen in the smart buildings in the near future. So the evolution of smart buildings technologies are actually transforming, the landscape of modern architecture and the urban development. By leveraging the advanced systems and data analytics, these technologies offer numerous benefits, including energy efficiency, enhanced comfort, and improved safety. So when we look into the future, the integration of AI, sustainable practices, advanced connectivity, they will continue to shape the evolution of smart buildings and make them an essential component of our built environment. So the pathway to building energy efficiency, improving energy efficiency in building sector is actually essential for achieving sustainability goals and reducing the environmental impact. by implementing innovative design strategies, retrofitting the existing structure, integrating renewable energy sources, and adopting smart technologies, significant energy savings can be achieved here. And also, since it is building sector, it is always continue to evolve. Ongoing research and development will be critical in identifying new opportunities for energy efficiency improvements. So the next section is GSG estimation. In the previous slides, we saw GSG mitigation. So GSG estimation technique in the building sector, there are 3 subsections. So the first one, GSG estimation process, estimating the GSG emission for any sector, whether it is building or transport or industry or any sector. It is actually crucial for organization which are aiming to reduce the environmental impact. So energy audit, as I told earlier, facilitate this process by providing data on energy consumption, which can be converted into GSG emission using some established conversion factors are there, like emission factors. We will see in the future slides. So the major steps or the key steps in the GSG estimation through energy audit include: one is data collection, which is gathering the information on energy consumption from utility bills or equipment specification and the operational practices. 3 different aspects can be considered while collecting the data. You can check the utility bill, the KCB or any utility bill you can check for the energy consumption. The equipment specification you can check. Similarly, you can use the operational practices, how many hours a particular machine is using or a particular system is using. The second one is energy analysis, where evaluating the collected data. You are evaluating the collected data to identify the energy use pattern and inefficiency. And the third one is emission calculation. That is where you will apply some emission factor to the energy consumption data to estimate total GSG emission. And the fourth one is, obviously, you are making a report documenting the findings and providing recommendation for reducing the energy use emission. So here, what are the benefits of GSG estimation? You can see it is having different benefits. Obviously, there will be cost saving. As I told earlier, regulatory compliance, corporate responsibility, stakeholder engagement. These are the major points. So in the building sector, how we can do the GSG estimation technique? Like energy audit. So when you conduct a comprehensive energy audit, it will help to identify the areas of improvement, and it will quantify the potential greenhouse gas reduction. So the definition for energy audit is actually, it is a systematic assessment of energy use in building or process or systems. Anywhere you can do an energy audit. The basic aim is to identify the opportunity for energy efficiency improvement. So when you are going for energy efficiency improvement in any building or any process or any system, you can go for energy audit. So by quantifying the energy consumption and associated emission, this energy audit will provide a framework for institution or organization to understand their carbon footprint, and they can develop these results to develop strategies for this carbon footprint reduction. So the methodology for conducting the energy audit, the significance of GHG estimation, and the benefit of implementing energy efficiency measures can be seen in the next slides. So energy audit, as I told earlier, it's a comprehensive one. We are evaluating the energy consumption pattern. It involves analyzing the energy flow, identifying the various inefficiencies, and recommending measures to optimize the energy use. So it can be classified into 3 levels. One is walkthrough audit, which is a level 1 audit. That is, walkthrough audit is a preliminary assessment that provides a very general overview of energy use and identifies the major areas of improvement. It's just a preliminary level audit. You will not assess or analyze anything, but you will see a preliminary assessment will only be done. Whereas in the second level, which is a detailed audit, a more in-depth analysis is carried out, and it includes the detailed measurement and calculation to quantify or to assess or to estimate the energy saving and GST reduction. And the third level is the investment grade audit. So there a thorough examination is done, which can provide a detailed financial analysis also. That is, the cost benefit analysis will be done for the different energy saving measures, which will show the return on investment also will be done in this third level. So 3 different levels are there. One is the investment grade audit. Sorry, that is a thorough examination. Then there is the final one. Then before that, we will do a detailed audit, and it starts with a walkthrough audit. So GST estimation through energy audit, the estimation of greenhouse gas emissions can be done, and the different levels are data collection, then we will do the energy analysis, then the emission calculation, and then the reporting. So what are the benefits of implementing these energy efficiency measures are shown in this slide, that is reducing energy cost, etc. So the benefits of energy audit implementation, one is the reduced energy cost. So when you implement the energy audit result, obviously your energy cost will get reduced. So an efficiency measures often lead to lower the utility bill. The second one is lowering the GHG emission. By decreasing the energy consumption, obviously organizations can significantly reduce their carbon footprint. Then improving the comfort and the productivity. So building system enhancement will be done based on the energy audit. So when you do energy audit, automatically the existing system will get enhanced. So automatically we will have better indoor air quality, IAQ, and the comfort for occupants. So it will automatically improve the comfort and obviously the productivity of the people. The fourth level is increased asset value. That is, energy efficient buildings are obviously more often attractive to its tenants, buyers, and leading to higher property value. So these are the major benefits of energy audit implementation. So the role of energy audit in sustainability. So this energy audit actually serves as a powerful tool for estimating the greenhouse gas emission and identifying the opportunity for energy efficiency improvement. So by systematically analyzing the energy use and implementing recommended measures, any organization can reduce the environmental impact, and they can achieve the cost saving and they enhance their reputation among the society. Also, there is also the urgency to address the climate change continues to grow in the national level. Energy audit will play a crucial role in helping the organization to that is the transition towards a more sustainable future. So that they are actually the role of energy audit in the sustainable society. So the next section is GHG estimation using life cycle assessment. That is another process. Life cycle assessment process, or LCA, it actually evaluates the environmental impact of building materials and systems throughout the life cycle. That is providing insight into GHG emission. So this LCA, life cycle assessment, is actually a comprehensive tool, or it's a method that evaluates the environmental impact associated with all stages of a product's life, from the raw material extraction through production, use, and disposal. So it is starting from the raw material extraction up to the disposal of that particular product. So by understanding the life cycle assessment and its role in GHG estimation, any stakeholder can make informed decision to reduce their carbon footprint and promote sustainability. So life cycle assessment process, it actually encompasses different phases. It includes the goal and scope definition, which is actually establishing the purpose of the assessment and definition of the boundaries of the study. We have to establish what is the purpose of this assessment, and we have to define the boundary of our study. Second one is inventory analysis, that is collecting data on energy and material input, its output, and including emission and waste. Then the third one is impact assessment, where evaluation of the potential environmental impact based on the inventory data will be done. Fourth one is interpretation, that is you will do the analysis or analyzing the result. to draw conclusion and make recommendations. So these are the 4 steps in life cycle assessment: goal and scope definition, inventory analysis, impact assessment, and interpretation. So importance of GSG estimation in life cycle assessment, that is estimating the GSG emission, is crucial for understanding the climate impact of product and services. So this LCA, it provides actually a holistic view of emission across different life cycle stages. It will allow for the identification of hotspots where you can reduce or reduction of energy consumption can be done. Also, this is essential for different businesses which are aiming to meet particular regulatory requirements. If some businesses will always try to improve the sustainability, and some of them want to enhance their market competitiveness. So all these areas, this life cycle assessment is essential too. So different techniques for GSG estimation in life cycle assessment are given here: process-based LCA, simplified LCA, hybrid LCA, input-output LCA, that I will present in the next slide. So the first one is process-based LCA. This technique actually involved a detailed modeling of each process involved in the life cycle of a product. So it requires extensive data collection and can provide accurate estimate of emission. However, this process-based life cycle assessment is actually 2 drawbacks are there. One is it is very time consuming, and it is also resource intensive. So the process-based LCA, it actually involves modeling of each process involved in the life cycle. Process analysis will be done, and they have particular emission factors. What are emission factors? I will cover in the next slides. So the drawback is time consuming and they are resource intensive. The next one is input output LCA. So input output analysis in the life cycle assessment, they use economic data mainly. They use the economic data to estimate the emission based on the different interdependencies between different sectors of the economy. And this method is actually less detailed than the process-based LCA, but they can be useful for screening, assessment, and understanding the economic impact. A broader economic impact can be assessed using the input-output LCA, whereas the process-based LCA gives importance to the process, whereas the input-output analysis LCA gives importance to the economic analysis. The third one is hybrid LCA. So it is actually combines the elements of both process-based LCA and input-output approaches. So it actually leverages the strength of both methods to provide a comprehensive assessment, and at the same time, mitigating some of the limitations inherent in each approach can be avoided in using hybrid LCA. So nowadays, most of the life cycle assessment is done by using hybrid LCA, not process or input-output. And there is a simple one, which is simplified LCA, simplified life cycle assessment. It is actually for some quick assessment of preliminary evaluation. Simplified LCA methods can be employed. So these methods use very generic data and assumption to provide a rough estimate of GSG emission, making them suitable for initial screening, but they are less reliable for a detailed analysis. So these are the 4 different life cycle assessments: simplified LCA, process-based LCA, hybrid LCA, and input-output LCA. Among them, the best one is hybrid LCA. So the challenges in GSG estimation through life cycle assessment. So even though the LCA is a very powerful tool for the greenhouse gas estimation, it has certain challenges. One is the data availability. So when you do the life cycle assessment, you should get high quality region-specific data, which are difficult to obtain in many cases. So it will always lead to uncertainty in the assessment. So data availability is a major problem. Then the assumptions and boundaries. When you define the boundary of the study and making assumptions, it can significantly influence your results. So when you take the assumption and when you fix the boundaries, it is having very high impact on your results. So that is another issue, assumptions and boundaries. The third one is the system complexity. There are interconnectedness of various processes and their impact, which can complicate the analysis. So when you do the life cycle assessment, these three are the major challenges. Data availability is a challenge. The system complexity is another challenge. The assumption and boundary fixing, and that is having another influence on the result. So the importance of life cycle assessment, it is actually, even though there are challenges, it's a vital tool for estimating the GHG emission and understanding the environmental impact of products and services. By employing various estimation techniques, stakeholders can identify opportunities for emission reduction and contribute to more sustainable future. So even though there are challenges associated with LCA, it's a comprehensive one. It's comprehensive nature, make it as an essential tool for informed decision making while we are looking for sustainability. So another one is benchmarking, that is comparing the energy performance against a similar building that can help the best practices and areas of improvement. So the building energy performance comparison, benchmarking is another tool. Like life cycle assessment, people will look for benchmarking, which is comparison of energy performance of a particular building with a similar building, so that you can identify some best practices if they have, and the various areas of improvement can also be done. This is another method. So with this, the building sector GHG mitigation and GHG estimation techniques are over. Now coming to the transportation sector, similar to building sector, mitigation, estimation techniques, both are there for the transportation. So transportation sector starts with the electrification of transport, then public transport enhancement, active transportation promotion, and fuel efficiency improvement, alternative fuel development. So these are the factors, these are the points to be covered here in the transportation GHG mitigation sector. These points are explained in the previous slide, that is electrification, public transport, active transportation, fuel efficiency improvement, and alternative fuel development. So the first one is electrification of transport. Electrification, you know about electric vehicles, EVs. So transitioning to EVs can significantly reduce emission. Even though there are so many problems identified in now, they are only in now. In future, it will not be there. So especially these EVs, which are going to be powered by renewable energy. Similarly, there will be public transport electrification. Electric buses are there. Electrifying buses and trains can lower the emission in urban areas. So the shift to electric and hybrid vehicles. The rise of electric vehicles, also there are hybrid vehicles which represent a significant shift in the transportation sector. So these vehicles actually utilize the electric power to reduce the fuel consumption and emission. So the governments worldwide are promoting the electric vehicle adoption through incentives, infrastructure development, such as charging stations. One of the most promising techniques for GHG mitigation in transport is the electrification, as I told earlier. So this includes adoption of electric car, buses, truck, two-wheeler, which can significantly reduce the emission, especially when powered by renewable vehicles. So the benefits are, here actually you are reducing the tailpipe emission. You are not reducing the overall emission, because when you use electricity, if the electricity is produced by renewable sources, then the tailpipe emission, not only you are considering the tailpipe emission, but if you are producing the electricity using coal, or if you are producing the electricity using fossil fuel, any fossil fuel, the tailpipe emission only you are reducing. That you have to remember. So at the same time, you are considerably lowering the operational cost because of cheaper electricity compared to fossil fuel. And there is potential for energy storage and grid stabilization. That is another aspect, another benefit. At the same time, there are challenges. One of the major challenge now high initial cost for the electric vehicle. Similarly, charging infrastructure is very limited in many regions. Third one is the production, battery production and its disposal will make more environmental concerns. So these are the major three challenges in the electrifying the transport sector. The second one, public transportation enhancement, that is travel demand modeling. So public transportation enhancement, that is you are improving the public transportation system, which can lead to a significant decrease in greenhouse gas emission by reducing the number of individual vehicles on the road. So the benefits are obviously increase the efficiency and reduce the congestion, lower the per capita emission compared to private vehicle use, and enhance the accessibility for communities. So these are the major three benefits. So that is shown here, how we can reduce the GHG emission through public transport enhancement. Different points are given in this one. So one is fleet management system, that is implementing a thorough fleet management technology can optimize the routes and reduce the fossil fuel consumption, leading to lower emission. And the fleet management system or the public transportation enhancement challenges, funding and investment requires, which is required for the infrastructure development. That's a challenge. And public resistance to using public transport, that is another challenge in many regions. And integrated transport systems are required. Transport system integration is required. That is, connectivity should be improved. That is another challenge. So for that, people have to do in transportation travel demand modeling. So it's a critical aspect of transportation planning, this travel demand modeling, which will help to predict the future travel pattern and assess the impact of various factors on transportation system. So here we will discuss an overview of travel demand modeling, including its purpose, methodology, and application in urban planning and policy making. So for travel demand modeling, it's a tool for understanding how people move within and between different areas. So in a neighborhood, how the people are moving within the neighborhood, or from one neighborhood to another neighborhood, how the people are moving in different areas. That is actually you can understand that by using travel demand modeling. So here you have to analyze certain factors like population growth, land use changes, transportation infrastructure. After analyzing all these major factors, population, land use changes, transport infrastructure, the planners can forecast travel behavior and make informed decisions about transportation investment and policies. So the major components or the key components of travel demand modeling, the methodologies and the significance will be discussed from hereafter. The first point is trip generation. For travel demand modeling, the major first component is trip generation. That is, it estimates the number of trips originating from or destined to a specific area. For that, the planners will use land use characteristics, the demography, and the economic factors. So trip generation is a major first initial step that you have to do. That is, it will estimate the number of trips originating from or destined to a specific area. So after trip generation, the second one is trip distribution. Sorry. So once you do the trip generation, once you establish the trip generation, the trip distribution model determines where the trip will go. So this involves analyzing the attractiveness of different destinations and the impedance or the cost or time associated with traveling to those locations. So the next step is, after trip generation, the next step is trip distribution. So there you will determine where this trip will go. So this involves analyzing the attractiveness of different destinations and the impedance, its cost, its time associated with traveling to this location. This is the second step. So the third one is mode choice. The third step is mode choice. After the trip generation, trip distribution, the third one is mode choice. So this aspect actually assess the transportation modes individuals choose for their trip, such as which mode are you using. It is a driving or public transit or walking or cycling, something like that. So the factors influencing the mode choice include the travel time, the cost, the convenience, and your personal preferences. So the next one is the route assessment process, the final component. After the mode choice, you have to, when you do the travel demand modeling, you have to do the route assessment. The final component involves assigning the predicted trip to specific routes within the transportation network. So this helps identify the congestion point and informs infrastructure improvement, how you can improve the infrastructure, and where are the congestion points, how it can be improved. So as I told earlier, this is a 4-step model, the travel demand modeling. It starts with the trip generation, trip distribution, mode choice, and route assessment. So it is a traditional approach in transportation planning. It includes the 4 steps like trip generation, distribution, mode choice, and route assessment. So still now people are using this model. It is widely used due to structured framework. It has a particular structured framework. So different travel demand models are there. One is called activity-based model. So these models actually focus on individual travel behavior and daily activities rather than just trips. So these models actually focus on individual activities rather than just trips. So they consider the very complex interaction between activities, travel, and it will provide a more nuanced understanding of travel demand, activity-based model. Another one is agent-based modeling. So agent-based modeling, they simulate the action and the interaction of autonomous agents like individual traveler to assess their effect on the transportation system. So this approach actually allows for exploration of various scenarios and policies. So agent-based modeling is there, activity-based modeling is there. Both these are used. In agent-based modeling, autonomous agents, individual travelers are used for modeling, assessing the effect on particular modeled transportation system. Whereas in the activity-based modeling, they focus on individual travel behavior. So these points are explained in this slide. That is travel demand modeling. You are forecasting the travel pattern, assessing the policy impact, infrastructure planning, understanding travel behavior, etc. So the application of travel demand modeling mainly for urban planning. When you plan a city, when you plan a new city, or when you plan the travel demand for a particular city, this type of models will assist the planners to make decision about the land use, zoning of the city, infrastructure development, and always it will accommodate the future growth also. So transportation policy, that is evaluating the potential impact of policy changes such as tolls or transit improvement or transportation improvement or travel behavior. So they are the major impact in this particular travel demand modeling section. Similarly, when you take a transportation system, parallel to that, you will have to do the environmental impact assessment, which is EIA. So analyzing how the changing transportation system affect the air quality of that particular zone or that particular neighborhood, the noise level of that particular zone, and the overall environmental sustainability. So that also will be done along with the travel demand modeling. So in travel demand modeling, when you do travel demand modeling, you have to do the policy impact assessment, and also you have to do the environmental impact assessment. Similarly, from data to the funding decision, that is funding and investment decision. So it will provide a data-driven insight to justify the transportation funding requests and prioritize the projects. So that also will be a part of the travel demand modeling. So the transportation planning through travel demand, it is actually an essential tool for policymaker and transportation planners. So by understanding the travel pattern and behavior, different stakeholders, especially the policymakers, can make informed decision that enhance the mobility, that reduce the congestion, and promote sustainable and the transportation solution. Also, especially in urban areas, which will continue to grow and evolve, the importance of accurate travel demand modeling will only increase, making it critical component of effective transportation planning. So that is actually a concluded remark for this particular travel demand modeling. GST mitigation technique in the transportation sector, active transportation promotion. So active transportation promotion, it is actually regional one. That is, in some particular regions, it is having very high impact. Biking, walking infrastructure development, that is developing bike lanes, pedestrian pathways to encourage the non-motorized transport. Carpooling, ride sharing, that is promoting sharing transport options, can reduce the number of vehicles on the road. Why I said this is regional, in some regions where the temperature is more than 50 degrees Celsius in a particular summer period extending from May to September, you cannot think about biking, walking infrastructure development. That is why I told active transportation promotion can be applied to some regions where the temperature is not that much high. Carpooling, ride sharing can be implemented in that manner also. The benefits are, there is benefits of active transportation, as you know, zero emissions from walking and cycling. Health benefits are also there, and the carpooling sharing will obviously reduce the traffic congestion and it will improve the air quality, etc. So the different pros and cons are explained here. So reduce GST emission, improve public health, etc. are the pros. Cons are also explained here. The challenges are, in any urban planning around the world, they will always prioritize vehicles over pedestrians and cyclists. There are very rare examples which are showing they are giving importance to pedestrians and cyclists, some European countries. So safety concerns in high traffic area is another challenge. Weather and geographical limitations that I told earlier, the temperature high countries. So that is another challenge. But still, many transportation planners, travel demand planners are looking for active transportation planning. The next one is fuel efficiency improvement in the transportation sector. So when you enhance the fuel efficiency of your conventional vehicle, fossil fuel I am talking about, through technological advancement, which can lead to GST reduction. So there is always global concern about the climate change, energy consumption. It will always continue to rise. So improving fuel efficiency has become a critical focus for any government, institutes, industries, and also for consumers. So this section, we will see the advancement in vehicle design, alternative fuel, regulatory measures, and the role of technology in achieving better fuel economy. So one is telematics and connectivity, enhancing the fossil fuel efficiency through telematics. So the integration of telematics and connectivity in vehicles allows for real-time monitoring of fuel consumption and driving behavior. The data can help drivers optimize their route and driving style, leading to improved fuel efficiency. The fleet management system also benefits from this technology, enabling companies to reduce the fuel cost. So telematics, the integration of telematics and connectivity in vehicles, it is actually like a Google map. Different other apps are also available. So the second point is regulatory influence on fuel efficiency. So governments actually play a crucial role in promoting fuel efficiency through regulations and standards. Like the initiatives such as corporate average fuel economy, CAFE standard in US, European Union CO2 emission standard, BS standard in India. So they will encourage the manufacturers to produce more fuel efficient vehicle. Also, these regulations not only drive innovation, but also help consumers make informed choices. So regulatory influence is also another factor like telematics. Then comes the autonomous vehicle. The development of autonomous vehicles has a potential to enhance the fuel efficiency. They will further enhance the fuel efficiency by optimizing the driving pattern and reducing the human error. Autonomous vehicles can achieve better fuel economy. In Dubai, autonomous vehicles are already flying in the last 2-3 years, especially for the police. And research is ongoing to assess the impact of these technologies on overall transport efficiency. Then comes the aerodynamics, that is the vehicle design innovation. So like telematics, regulatory, and the autonomous, the other parameter is aerodynamics. That is one of the primary ways, which is actually done in the previous years, very early stage development. Primary ways to improve the fuel efficiency is through better vehicle aerodynamics. So streamlined designs are there, which will reduce the air resistance, allowing vehicles to consume less fuel at higher speeds. So as you know, manufacturers are using the CFD, computational fluid dynamics, to optimize shapes and reduce the drag. Actually, 1998, 1999 onwards, Ashok Leyland is using this CFD technique to optimize the shapes, to reduce the drag. So the next one is lightweight material, which is a recent development. Earlier, people were using aluminum. Now they are using carbon fiber, which has gained traction in vehicle manufacturing. By reducing the overall weight of the vehicle, manufacturers can improve the fuel efficiency without sacrificing the performance. So this trend is particularly evident in automotive and aerospace industry. Then engine technology. So advancement in engine technology, such as TCAC, turbocharging, and direct fuel injection, they improved the fuel efficiency. So they will give, these technologies actually allow the engine to extract more power from less fuel, leading to better performance and lower the emission. How to improve the fuel efficiency? One way is hybrid vehicle, another way is eco-driving training. So encouraging the use of hybrid vehicle can improve the fuel efficiency and reduce the emission. So eco-driving training, educating the drivers on eco-friendly driving practices, which can lead to lower fuel emission. So enhanced fuel efficiency for sustainable transport, you can always look for, it is actually a multifaceted challenge, which require collaboration from manufacturers, government, consumers, everyone. The benefits, as I told earlier, it can reduce emission, lower fuel consumption, cost saving, immediate applicability are also there. And the challenges are, that is fuel efficiency improvement challenges, technological limitations are there, which are still ongoing research is going on. Potential rebound effect, where increased efficiency lead to more driving. People will drive more when there is more fuel efficiency. So regulatory hurdles are also there, which is there in implementing the efficiency standards. So these are the GSG estimation technique. So the next one is alternative fuel development. That is the adoption of biofuels are not that much adopted. Hydrogen is adopted. Synthetic fuels are adopted, which can reduce reliance on fossil fuel, especially blue hydrogen, green hydrogen are the alternative fuels. So the biofuel system, mainly they are developed from organic materials, offer a renewable kind of or alternative to traditional fossil fuel, but not that much incorporated in the regular system. But many countries are still investing in the R&D to improve the production and efficiency of biofuel. But hydrogen fuel cells are another promising alternative for improving the fuel efficiency. So they produce electricity through the chemical reaction between hydrogen and oxygen. Only the emitting thing is water. Water vapor as the byproduct. So they are still in the early stage of commercialization. Hydrogen fossil fuel have the potential to revolutionize the transportation sector. That is for sure. So the benefits of this alternative fuel as diversification of energy source, lower life cycle emission. It has the opportunity for rural economic development. That is biofuel, alternative fuel, they can produce in the rural sector. At the same time, the challenges are competition for land and resource with the infrastructure requirements are required. Long-term sustainability uncertainty is there. They are the major challenges. So sustainable transport, what will be the future? That is mitigating the GHG emission in transport sector is essential for achieving global climate goals for any country. So even though there are many challenges, there will be benefits for the system. That is collaboration among different governments, industries, communities, etc. are required. The last section is estimation technique, benchmarking, emission factor analysis for transportation, key emission factor, etc. Greenhouse gas estimation involves, in the transportation sector, quantifying the CO, CS4 and nitrous oxide. So various techniques for estimating the GHG emission include direct measurement, emission factor, and modeling. So the first one is benchmarking. Benchmarking is it's a very critical tool to compare the GHG emission against an established standard or best practice. Like in the building, I told benchmarking means you are comparing with an existing building, but here there is an established standard. So by understanding and implementing the effective benchmarking technique, entities can identify the areas of improvement, standard, etc. can be set, etc. So as I told in the previous slide, industry standards are there. They will provide a baseline for GHG emission based on sector specific data. And mainly the common standards are like ISO 14064, that is greenhouse gas protocol is there. Common standard used in greenhouse gas protocol is ISO 14064. Other one is peer comparison, that is benchmarking against the peer involves comparing an organization's emission with that of the same industry. So that is another parameter. So the third one is historical data analysis. And the fourth one is sectoral performance metrics. So the sectoral performance metrics provide a framework for evaluating emission relative to production output or other relevant indicators. For example, emission per unit of product produced can help organization understand their efficiency and identify opportunity for improvement. Then the other one is geographic benchmarking is there. That is, geographic benchmarking involves emission across different regions or countries. So this technique can actually highlight variation in emission due to factors such as energy source, regulatory environment, and technological advancement. So the benefits of benchmarking, it can identify the best practices, it can set realistic targets, enhancing the accountability, facilitate reporting, etc. are the major benefits of benchmarking. Next is emission factor for transportation sector. So emission factor, actually they are very crucial for understanding the environmental impact of different transportation method, because they quantify the amount of pollutants released per unit of activity, such as a particular distance traveled or fuel consumed. So this information is very much important for policymaker or in scientific field researcher and the public to make informed decision regarding the transportation choices. Overview of emission factor. Emission factor varies significantly depending on the type of vehicle, fuel type, and operational condition. So they are typically expressed in terms of grams of pollutant emitted per kilometer traveled, that is grams per kilometer, or per liter of fuel consumed, grams per liter. So the main pollutants always considering are CO2, nitrous oxide, particulate matter PM, and volatile organic compounds VOCs. So CO, CO2, NOx, PM are the major ones that is considered here. So factors affecting the emission for various mode of transportation are given here. The first one is road transport, which is obviously the largest contributor to transportation emission. In India also it is not different, it is same. So the emission factors vary based on different type of vehicle and fuel used. For passenger car, you can see approximately 2.3 kilogram of CO2 per liter of petrol consumed. That is the emission level. Buses it is around 3, two-wheeler it is 1.8 kilogram, heavy duty truck it is approximately 2.7. These are some numbers you can see, Google it and you will see the numbers. So compared to rail transport, it is generally more efficient and has lower emission per passenger kilometer compared to road transport because of the number of passengers are more. So electric train, the emission factor depends on the source of electricity. Remember, emission factor depends on the source of electricity for electric train. And average emissions are around 0.1 kilogram CO2 per passenger kilometer for electric trains. Approximately, it is around 0.1 kilogram of CO2. But for diesel train, it is approximately 0.4 kilogram CO2 per passenger kilometer. In aviation, it is differentiated into domestic and international. For domestic, it is 0.2 and international, it is 0.15 kilogram CO2 per passenger kilometer. And for shipping, it is differentiated into cargo and ferry ships. So cargo ships emission factor around 0.01 kilogram CO2 per tons kilometer. And for ferry, it is 0.02 kilogram CO2 per passenger kilometer. So emission factor assessment, lack of sustainable solution, limited electric vehicle adoption, inefficiency, insufficient policy support, etc. are there the major factors. After reducing the emission factor analysis for transportation sector. So how we will do the emission factor analysis? Emission factors are actually the coefficient that quantify the emission of pollutant per unit of activity such as fuel consumption or industrial production. So understanding this emission factor and their analysis is essential for estimating the environmental impact of different activities and for developing strategies to reduce the emission. And this analysis will give some methodology for calculating the emission factor, their application, etc. Emission factor analysis in India, where there is rapid industrialization and urbanization are occurring, accurate emission factors are vital. Important point. They are typically expressed as mass of pollutant emitted per unit of activity, such as gram of CO2 per megajoule of fuel burned. So these factors can vary significantly. They can vary based on the type of fuel, based on the technology used, and based on the operational conditions. Emission factor analysis for transportation sector. That is how you are calculating the emission factor. One is the direct measurement. It is you are directly collecting the data from source of emission using a specialized equipment like pollution measuring equipment. For the smoke test, pollution test, you all know how you are doing the pollution test. That is the direct measurement. So most accurate emission factor you will get from the direct measurement. It is costly, it is time consuming. It often used in research studies and regulatory compliance assessment. The second one is emission factor database. So various organizations have the emission factor database. It's like US EPA, US Environmental Protection Agency, they have the AP42, their emission factor database. Similarly, various organizations have their own emission factor database. So when you cannot have the direct measurement, estimation techniques can be employed. So that is the estimation technique. So these methods often rely on the statistical model and the assumption based on similar activity. And while less accurate, they can provide useful approximation. That is the estimation technique. So emission factor analysis for transportation sector and application of emission factor. Here you will see regulatory compliance. That is, emission factors can help in calculating the total emission. And they can also help the climate change mitigation. And they can help in environmental impact assessment. So especially for project planning, development, people will use the emission factor to evaluate the potential environmental impact. And you may be knowing about SDG, UN SDGs. That is Sustainable Development Goal. So the challenges in emission factor analysis, even though they are having very high importance are there, certain challenges are there. One is the variability. That is, emission factor can vary widely based on local condition. So you cannot apply a single factor in a universal level. It will vary. And there are data gaps. In some sector, particularly emerging technology, there may be insufficient data to develop a reliable emission factor. And there are challenges over time. As technology evolve and regulations change, the emission factor may need continuous update. So these are the major challenges. Key emission factor database for India. Indian Network for Climate Change Assessment, INCCA. It's a prominent initiative by the Ministry of Environment, Forest and Climate Change in India. They provide a comprehensive database for emission factor for various sectors, including energy, industrial process, agriculture, etc. And this database is regularly updated every year to reflect the latest research and technological advancement. So another one is Central Pollution Control Board of India. So CPCB, they maintain a database of emission factor primarily focused on air pollutants, whereas in the previous one, they will have all kind of pollutants, they have a database. So this database is essential for assessing the quality and formulating strategies to combat the pollution, especially in the urban areas. So the CPCB data, emission factor data, is mainly utilizing in the urban areas. So they collaborate with the various stakeholders to ensure the accuracy and the relevance of the data. Then comes the NIR, National Inventory Report. So they compiled by the MOEFCC, and they includes emission factor used for the national greenhouse gas inventory. So they provide a detailed methodology for calculating the emission from various sectors, different sectors, and aligned with the guidelines set by the IPCC, Intergovernmental Panel on Climate Change. So National Inventory Board is another one. So in addition to these databases, there are international sources. So international sources such as IPCC, Global Carbon Project, they provide emission factor that can also be adapted to some extent to use in India. So they have a broader context and can help validate the local data. You can validate the local data with the international bodies like IPCC. Importance of emission factor analysis, as I told in the previous cases, one is the policy development. Emission factor database can provide necessary data for policymakers, inventory compilation, research and analysis. These are the major important factors. Cycle of emission factor database utilization, I have shown here, that is sustainable future, etc. are there. Then there is a small section, UN SDGs, Sustainable Development Goal. So even though there are 17 SDGs, 2 of them are mainly connected with the building transportation sector. One is Goal 13, which is climate action. The other one is Goal 7, affordable and clean energy. So among the UN SDGs, these 2 are mainly connected with what we are considering now. Goal 7, affordable and clean energy, they ensure these goals are actually applicable to India also. So when you think about the energy and climate, you have to look for Goal 7 and the Goal 13. So the Goal 7 ensures universal access to affordable electricity, increase the share of renewable energy in global energy mix, double the global rate of improvement in energy efficiency. These are the major parameters or major points to be considered in Goal 7. As per the UN SDG, this is the pathway for sustainable energy. And the Goal 13 focus on urgent action to combat the climate change. So strengthen the resilience and adaptive capacity to climate-related hazards, integrate climate change, improve education, etc. So importance of energy and emission goals, that is how to achieve the Goal 7 by supporting from Goal 13, that is the cycle of renewable energy and emission reduction. So the interconnection between the energy production and the greenhouse gas emission is critical to fight against the climate change. So the transition to renewable energy sources not only help the goal 7, but also it plays a vital role in reducing the emission, thereby supporting the goal 13. So mainly by focusing these two goals, goals 13 and goal 7 of UNSDG, any country can work towards a sustainable energy future, at the same time mitigating the adverse effects of climate change. So for energy and emission, UNSDG, it is actually a guideline or guiding a framework for any nation, any organization to create a sustainable future. So with this, I am concluding. Any questions? Thank you, everyone, for your patience and listening.
Any questions from participants?
I saw one question. What are the software available for travel demand modeling? Yes, for travel demand modeling, one is Transcad. TRANSCAD. Transcad is available. Cube is available by City Labs. Cube. Actually, for transportation modeling, Cube is one of the widely used software. It is actually suitable for travel demand forecasting, network analysis, optimization. Multi-modal analysis can be done. Auto, transit, walking, anything can be done in Cube. CUB Cube. Then Transcad also is a good one. It is actually GIS based transportation planning software. Then another one is TMIP tool, that is Travel Model Improvement Program tool. That is there. TMIP is a model development guideline one. Then VISUM is there. VISUM is there. I have no idea about this VISUM, but the main ones are Cube and Transcad are used. Also, there is another one called TranPlan. TranPlan is actually a widely used software for travel demand modeling. Trial version available, yes. Trial version available. Education version is also available for academic institutes.
Thank you, sir, for this session. On behalf of all the participants and College of Engineering, Uttarakhand, I express our deepest appreciation for taking the time to share your knowledge with us. Thank you, sir.
Thank you. Thank you for the invitation, and I hope it is somehow useful for everyone.
Thank you, sir. Thank you.
Thank you, sir.